Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 5 video on the topic of area of a trapezium and polygons, where I will discuss about how to find the area of a quadrilateral. If you have not watched the previous 4 parts where I have already discussed how to find the area of a trapezium and solve the problems of exercise 18a, then I highly request and suggest that you please watch those videos also. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel, or if you are watching this or if you are not yet subscribed, and if you are watching this video for the first time and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel. And also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 5 video in discussing how to find the area of a quadrilateral. Okay, we have already discussed how do we find the area of a trapezium and isosceles trapezium in the previous videos. I hope you have already watched them. In this video, we will discuss how to find the area of a quadrilateral in general. That is, it is simply a regular quadrilateral. It is not any special quadrilateral, like it is not a kite, a rhombus, or rectangle, or square, or even trapezium or isosceles trapezium. It's a simple quadrilateral having 4 sides, which is a polygon of 4 sides. Okay, so how do we find? The concept is that since a quadrilateral is a polygon of 4 sides, each diagonal will bisect a quadrilateral into 2 triangles. So the idea is to find the area of the 2 triangles and add the area of those 2 triangles, which will give the area of the entire quadrilateral. So using one diagonal, we will divide the quadrilateral into 2 triangles. So as you can see in this, I have in this quadrilateral ABCD on the left hand side. So since there are 2 diagonals in a quadrilateral, using any one of the diagonal, I can divide so in 2 ways I can divide the diagonals into 2 triangles. On the left hand side, let's say I am using the diagonal. If I use the diagonal AC, let's say AC, so I will add, so I have a triangle ABC and the triangle ADC. So the area of the quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC. Now so how do we find the area of triangle ABC? We will need, using the formula half into base into height, we will need the height and base of the triangle ABC, as well as to find the area of ADC, we will need the height and base of the triangle ADC. Now we will, using minimum information, we will use AC as the common base for the triangle ABC and ADC to find the areas. We will use AC as the common base. So we will now need the height of the triangle ABC where AC is the base. So we have to draw a perpendicular from B on the side AC. Let's say BE is perpendicular to AC. That is, BE will be the height of the triangle ABC, considering AC as the base. Similarly, considering AC as the base of triangle ADC, we will have to draw a perpendicular from D to AC. Let's say this is the perpendicular DF is perpendicular to AC. So let's say the length of BH1 and the length of DFBH2. So now what will be the area of triangle ABC? The area of triangle ABC will be equal to BE, so AC is the base, AC is the base and BE is the height, BE is the height. And what will be the area of the triangle ADC? It will be half, its base is also AC and its height is DF. This is equal to half multiplied by AC. BE is H1 and we have half multiplied by AC multiplied by DF is H2. DF is H2. So this becomes, after simplification, this will become half multiplied by AC multiplied by H1 plus H2. So the formula becomes, so in this quadrilateral ABCD, if we know the length of the diagonal AC and also if we know the sum of the lengths of the perpendiculars drawn on AC from the vertex D and B, or the individual length of the perpendiculars drawn from the point vertex D and B on the diagonal AC, we can find the area of triangle ABCD. So the formula is half into the length of the diagonal AC multiplied by the sum of the length of the perpendiculars on AC from vertices D and B. So this is the formula if we consider the diagonal AC. On the right hand side, if we consider the diagonal BD, let's say we are considering the diagonal BD. So BD will now divide the entire quadrilateral into triangle ADB and BDC. So we have area of ABCD, that is the quadrilateral ABCD, will be equal to area of triangle ADB plus area of triangle BDC. So similarly, as we did on the left hand side, we will have to consider, we will have to draw the height. We will have to consider BD as the common base of these two triangles, and we will have to draw the height of the two triangles. So for the triangle ADB, let AE be perpendicular to BD. So AE will be the height of the triangle ADB. Similarly, from the vertex C, let CF be perpendicular to DB, and let AE be, let CF be H2, the length of the line segment C perpendicular CF be H2, and the length of the perpendicular AE be H1. So now the area of triangle ADB becomes half into base is BD and its height is AE, plus the area of the triangle BDC becomes half into base is same BD and multiplied by its height is CF. So this is equal to half multiplied by BD multiplied by AE is H1 multiplied plus half BD multiplied by CF is H2. So after simplification, this becomes half multiplied by BD multiplied by H1 plus H2. So the formula is same. This time, since we have considered BD as the diagonal, the area of the quadrilateral will be half multiplied by the diagonal BD, length of the diagonal BD multiplied by the sum of the lengths of the perpendiculars drawn from the vertices A and C on the diagonal BD. So this is the basic formula of finding the area of a quadrilateral. We need the length of one of its diagonal and the sum of the lengths of the perpendiculars drawn on that diagonal from the two vertices of the quadrilateral. Okay. So now based on this concept, let's solve two example problems. So the first problem, please try to solve this problem yourself first. If you are stuck or if you want to see my way of solution, please you can see this. You can first try to solve these problems yourself first by pausing the video, and then if you are stuck or if you want to see my solution, then resume my video and see my solution. Okay. So the first problem says that in the quadrilateral ABCD, AF is perpendicular to BD and CE is perpendicular to BD. Okay, so in the quadrilateral ABCD, BD is the diagonal and AF and BE are perpendicular to BD. The area of ABCD is double the area of BCD. The area of ABCD, that is the quadrilateral ABCD, is double the area of triangle BCD. Then the ratio AE is to CF. AE is to CF. Then the ratio AE is to CF is, okay. The area of triangle ABCD is double the area of triangle BCD. Okay. Now fine. Okay. Okay. So let's say let the length of AF, the perpendicular AF on BD be H1, and the length of CE, which is perpendicular to BD, as H2. So that is, let AF equals to H1 and CE be equal to H2. Okay. Now the area of ABCD. Okay. So based on the concept of area of a quadrilateral ABCD, it will be now, so area, let's say capital A of ABCD will be equal to, we know, if we consider BD as the diagonal, it will be half BD multiplied by the sum of the perpendiculars drawn from the vertex C and A on BD, which and the perpendiculars are AF and CE. So this will be H1 plus H2. Okay. Now what is the area of the triangle? BCD. Area of triangle BCD is, considering BD as the base and CE as the height, it will be half BD multiplied by H2. Now it is given that the area of ABCD is double the area of triangle BCD. So given that A is equal to, let's say the area of triangle BCD be A1. So it is given that A is twice A1. Now this implies that what is A? A is half multiplied by BD multiplied by H1 plus H2. And what is twice of A1? A1 is half multiplied by BD multiplied by H2. Okay. So this implies that we can cancel out BD from both sides. Since BD is not is a non-zero quantity, we can cancel out. So we have H1 plus H2 divided by 2 is equal to H2. Now doing cross multiplication, we have h1 plus h2 is equal to twice of h2. This implies bringing the h2 on the right hand side, we get h1 is equal to twice h2 minus h2 is equal to h2. So we get that h1 is equal to h2. We found that h1 is equal to h2. We have to find the ratio of AE and CF. So how do we link, how do we relate AE and CF? We have to relate, because we have found that H1 is equal to H2, that is CE is equal to AF. But how are the line segments AE and CF are related to the line segments CE and AF? As you can see, AECF is a quadrilateral. Okay, now see that let me there is no space left. Okay, so please note that CE is perpendicular to BD. Second friend, CE is perpendicular to BD, and we have AF is perpendicular to BD. Both CE and AF are perpendicular to BD. This will imply that CE is parallel to AF. CE is parallel to AF. Also, and we have found that H1 is equal to H2, which means that CE is equal to AF. So in quadrilateral AFCE, we have found that CE is equal to AF and CE is parallel to AF. That is, the opposite side CE and AF are both parallel and equal. So in quadrilateral AFCE, we have found that CE is parallel to AF and CE is equal to AF. That is, one pair of opposite sides CE and AF are both parallel and equal. So we know that in a quadrilateral, if one pair of opposite sides are both parallel and equal, it will be a parallelogram. So this implies that AFCE is a parallelogram. So this will imply that the opposite sides AE and CF are equal. Opposite sides AE and CF are equal. So we have this equal to this and this equal to this. So we will have, since AFCE has been proved to be a parallelogram, we will have AE equal to CF. We will have AE, that is, the opposite pair of the opposite sides in a parallelogram are equal. AE equal to CF. This implies the ratio AE and CF is obviously the ratio AE and CF will be equals to 1:1. So the correct choice is C. C is the correct choice. Okay, let's do the next problem. In the quadrilateral PQRS, the diagonals PR and SQ intersect at the point O. Okay, if angle ROQ is 90 degree, ROQ is 90 degree, angle P is equal to angle R is equal to 100 degree, PO is equal to X, and the area of PQRS is capital A, then what is the length of OQ? If SO is to OQ is 1:m? Lots of information. Okay. So in the quadrilateral PQRS, diagonals PR and SQ intersect at the point O. Okay. So ROQ is 90 degree, angle ROQ equals to 90 degree will imply that all these angles will also be 90 degree. This will be 90 degree, this will be 90 degree, and this will be 90 degree. So we can say that PR and SQ intersect at right angles. Intersect at right angle. That is the diagonals PR and SQ are intersecting at right angles. They are not bisecting. Remember, they are only intersecting at right angle. Okay. And also it is given that angle P is equal to angle R. Now angle P is equal to angle R. This is given. So in a quadrilateral where these two information that in a quadrilateral, if the diagonals intersect at right angles and two opposite angles are equal, then it has to be a kite. So this implies that PQRS, I hope to understand this you must be familiar with the geometrical structure of kite and all its properties. If you wish, if you desire, you can also watch my video on kites in the same playlist. So this will imply that PQRS is a kite. Now we know that in a kite, two adjacent sides, there are one pair of adjacent sides are equal. We have two pair of adjacent sides equal, and also the opposite sides are unequal. Now in a kite, we also know that in a kite, if angle P is equal to angle R, then definitely the diagonal PR is bisected by the diagonal SQ. I will not explain, I will not discuss about the reason why the diagonal PR will be bisected by the diagonal SQ. For this, you can please watch my video on kites. Where, in the same playlist with the title from the chapter of parallelograms on the topic of kite. So so the idea is that in a kite we know the property property of a kite is that so a kite has two opposite angles equal, and the diagonal that connects that two opposite angles is bisected by the other diagonal. So in this figure we must have PR is bisected by SQ. PR is bisected by SQ. So this will imply that PO will be equal to POR. PO will be equal to OR will be equal to X, as PO is given to be X. Okay. And the area of PQRS is A. Okay. And also note that another property of a kite is that the diagonal which is not bisected in a kite, which is SQ, that diagonal will divide the entire kite into two equal triangles. In this case, the triangles are SPQ and triangle SRQ. So area, since PQRS is a kite and the diagonal PR is bisected by the diagonal SQ, we will have area of triangle PSQ will be equal to area of triangle SRQ. Since the diagonal SQ, that is the diagonal which is not bisected, that will divide the entire kite into two congruent triangles. Okay, so we have this. Uh, okay. Mm, fine. So what is what is the so we know so what is the area of triangle PSQ? Area of triangle PSQ will be equal to half the base we can consider as SQ and the height as PO. It will be SQ multiplied by PO, which is equal to SQ multiplied by X. PO is X divided by 2. Okay. Okay. The area of PQRS is given as capital A. That is, the area of the entire kite is given as capital A. Now, area, we know that area of triangle PSQ will be equal to area of ABCD, not ABCD, but the kite PQRS divided by 2, because the triangle PSQ and the triangle SRQ are congruent, so their area must be equal. So the area of angle PSQ should be equal to area of triangle area of kite PQRS divided by 2. This is equal to A by 2, as the area of the kite is given as capital A. The area of kite is given as capital A. Okay. So this implies we have SQ multiplied by X divided by 2 is equal to A by 2. This implies that SQ is equal to A by X. SQ is equal to A by X, where SQ is the diagonal SQ. Now we have to find the length of OQ. So we know the length of the entire diagonal SQ, and we know, and it is given that the ratio of SO and OQ, so we can easily find OQ. So this implies, what is SQ? SQ is SO plus OQ. This is equal to A by X, and it is also given SO is to OQ is 1:m. SO is to OQ is given as 1:m. Now from the concept of ratio and proportion, we can easily say that the value of OQ, or the length of OQ, will be equal to m by 1 plus m whole multiplied by SO plus OQ, that is A by X. This is equal to MA divided by X multiplied by 1 plus m. MA divided by X into 1 plus m. So the correct choice is C. So this was two problems based on the concept of finding the area of a quadrilateral using the formula that its area is half multiplied by length of a diagonal and multiplied by the sum of the lengths of the perpendiculars drawn on that diagonal from the two vertices of the quadrilateral. I hope this video will be beneficial to you in understanding how to find the area of a quadrilateral, and these two problems will give you a good practice of your understanding on this topic. So if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will discuss about how to find the area of irregular polygons with some example problems. So I will end the video here. Thanks for watching, and until the next video, take care and bye.